Okay, so 5.1, mid-segments of triangles. The book does a nice little proof on this, the coordinate proof, okay? But I'm going to jump right to the theorem and the piece of this that you need to know so we can do a couple examples. You're not going to be using this in a proof. It's more the idea that you need to be familiar with. We have the triangle mid-segment theorem, which gives us basically two pieces of information. We have triangle ABC, and we were to find the midpoints of AB and BC. Actually, it could be any two sides, but let's find the midpoints here. The theorem says if a segment joins two midpoints of the sides of a triangle, then two things occur. The midsegment is parallel to the third side. So if we were to connect those two, all right, that makes those two segments parallel. And the other piece says the midsegment, and we'll give this a name right now, the midsegment DE is half the length of the parallel side AC. Okay, so what that allows us to do is say, well, if this length is X, and that's half of the parallel side, then that parallel side should be twice as big, 2x. Okay. Remember, you're going to get numbers for these, you're going to get expressions in there. A lot of people see expressions and the first thing they want to do is set them equal. They are clearly not equal. You can see visually they are not equal. So if you start to set them equal, something in your brain should stop you and say, oh, wait a minute. They don't even appear to be equal, right? You can't cut a triangle in half and say that something in the middle is equal to something on the outside, all right? So that's what the theorem gives us. And again, there's a nice little proof using coordinates in the book. They basically assign coordinates to these 4 points. They use the distance formula to show the length here and the length there, and it comes out to be that this one is twice as big. And they also use the slope formulas with both segments to show that these two segments have the same slope, which indicates that they have to be parallel, because segments with or lines with the same slope would be parallel. So there's valid math behind these, okay? But we're going to actually talk about how to use the theorem. So the first example that we are going to look at we're going to put in midpoints for all 3 sides, and we're going to connect those midpoints. And we're going to apply some lengths in here as well. Now, the one thing you want to look for, we don't just assume because we see a point that is somewhere in between the other two and it looks halfway, we don't assume it is a midpoint. You either have to be told that these are midpoints or you need to see congruence marks. So we'll do a little bit of both. We're going to put the congruence marks in there. But then I'm also going to write down J is a midpoint and K is a midpoint. So one way or another, you need to know before you get started that each of these are midpoints. So there are two questions basically that we can answer, two concepts in this diagram. We can answer the question, what segments are parallel? And we can also find some lengths. Okay, so you'll be asked to do both with these questions. So let's start with JK. All right, what segment would be parallel to JK based on the theorem? Kaiser.
HK.
So JK and FE or FH, they're part of the same line. Okay, so this segment would be parallel to that one. It looks parallel, right? The other ones, do any other segments look parallel to JK? No. So these two here are parallel. So JK would be parallel to EF. Okay, the reason it can't be parallel to either of these is those midpoints are midpoints of these sides. So those obviously are the two sides that are not parallel. So it'd be the third side that does not contain the midpoint. So let's go with EG. Maybe they'll give you the long side. So EG here would be parallel to what segment? HJ. Okay, we're looking for the midpoints of the other two sides then. So EG is parallel to HJ. And then we also have, okay, let's do HK. HK is parallel to what? FG. Okay, so there are three sets of parallel segments that we can discuss based on the theorem and knowing that these are midpoints. And we can also work on finding lengths. So let's start here. We know that this is 60, and we know that this is parallel, so those also have a relationship when it comes to their length. Okay? We said that the long one is twice as big as the mid-segment, right? So the mid-segment is half as big as the longer side, or the side that it's parallel to. So if we know that KJ is half of EF, right? So KJ should be what length? Should be 30, because it is half of 60. So HJ then would be half of EG. So yes, HJ, we'll do that in a different color. So we know that EG is 100, so half of that would be 50. And then the final one, okay, if HK is 40, then how can we use that to find FG? Yeah, it should be half of FG, or FG should be twice as big as HK. So FG should be 80, yes? So those are the easy ones. When they just give you one number, you're either doubling it or taking half of it. Where people usually get a little bit mixed up is when they give you expressions or they give angle measures. You should also be able to find angle measures. So we're going to look at that. So we're going to find the measure of angle VUZ. So if you want, you could go over here and assign a variable, let's call this H, since we've already used X. What you should be noticing is that these are congruent and those are congruent, which make U and V midpoints, which makes UV a midsegment. And that doesn't tell us anything about lengths of our segments. We don't know what either of these are, but we should know that these two are parallel, yes? And going back to the chapter with parallel lines, what should be true about this angle and that one? Does anyone remember what kind of angles they are? These two angles right here, that one and that one. Good exam review. Remember there were those 5 types? They are same side, but they're not interior or exterior to the two parallel lines. They are corresponding angles, right? Same quadrant. If I were to extend these lines, see how they open up the same direction? When they're on the same side, but they're not interior or exterior, they're corresponding. So those are corresponding angles, and corresponding angles are congruent, which is good news because that makes those two angles congruent, which means H would have to be 65 degrees. So the measure of VUZ would be 65 degrees. Okay. So remember, your parallel lines, they come into play because those relationships that existed with the parallel lines, you might use them now and then. All right. Couple more examples. This one is a real life type problem. So you've got a lake and you want to know, says a new bridge is built over the lake, find the length of the bridge. Okay, if you could do a triangle around a shape in real life, and that's something they could measure, right? You know, you'd need probably some special equipment, but if this is where your bridge is going to go, if you can do a triangle and say, well, I've got C and D being midpoints, and I know the length of the third side is 2,640 feet. And I want to know how long the bridge is. Call that X. As soon as I know that these are midpoints, yes, those two would be parallel. That's not going to help me, but what would help me, Kaiser?
How long the bottom part of the triangle?
Yep. This part being parallel to that, or being the third side, should be twice as big as the mid-segment, right? So how do I find the length of the bridge?
Divide the 264 by 2.
Yep. It's going to be half of 2,640.
1,400.
Is that right?
4-sided.
Half of 2,640.
I put 294.
Yeah. So 1,320 feet would be the length of the bridge. Okay, it's a little real life application. Okay, we are going to do a couple of your homework problems.
We get one of those up brush.
Yes, I will have it for you tomorrow. I didn't get a chance to run off the copies. Okay, so number 2 is where they start throwing variables in. And you can see how easy it would be to go, oh, 5x is 70, and off you go. But that's not the case. They're not equal, okay? Here's what I'm going to recommend that you do. If these two aren't equal, and this one is half of the other, would it be correct to say that if I double this one, I should get the other? Yes? Okay, so what I'm going to recommend is you always go to the mid-segment, and here's what you're going to do to set up your equation. To make them equal, we're going to double that mid-segment and then set it equal to the parallel side. If you get in the habit of doing that, it doesn't matter where the expression is. The expression could be here, it could be there, but if you always go to the inside the mid-segment, you're going to double it. So our equation would be 2 times 5x equals 70. So 10x is 70. Divide out the 10, and x should be 7. So what this should save you the hassle of is when you get a problem like this, you're not trying to take half of 45, you're not in the habit of just setting things equal. What we're going to do, remember, is we're going to put parentheses if you've got an expression and double it, multiply by 2, and then we can set them equal. So you multiply by 2 first, so we have 2 times x minus 1 equals 45. Now you do have to remember to distribute. So this would be 2x minus 2 equals 45. Then the rest is your algebra. So add 2. So 2x is 47. Divide by 2. And x is 23.5. Okay. If you get a decimal or something like that, you can always plug this back in and check it. Make sure one is half of the other. Okay. Did everyone get the assignment written down?